Okay, great.
Okay, I think we're recording. I'm Joe Applebaum. I'm the president of the New York Thoroughbred Horsemen's Association. We were the lead sponsor of the Big Data Derby. Wande Owens, you want to just introduce yourself real quick?
Yes. Hello, my name is Wande Owens, and I'll be interning with Joe this spring.
Okay. I guess you guys are on.
Yeah, you can go ahead and start your presentation.
Yep. So you can see the slides, right?
Yes.
Right. So hello, everyone. I'm Ekaterina.
I'm Artem Volgin.
And together we're going to present our solution today. I'm going to talk mostly during the presentation, and then together we will answer your questions. So our submission was called Winning Strategies, What Works Better? And as you can see from the title, we were interested in identifying various strategies that jockeys use and estimating their effectiveness. Right, so what we're going to talk about today, first we're going to provide you with some sort of introduction about ourselves and about what we wanted to do in this competition. Second, we're going to walk you through the solution and share our findings, what we did and how we did this. This will be followed by discussion, some concluding remarks and Q&A. Right, so a couple of words about us. We are PhD students at the moment based in the UK, the University of Bristol and the University of Manchester. We are interested in applied statistics and social sciences. This is what our academic background is in.
Just really quick, yeah. We can only see your first slide, so I don't think you're in present mode.
Oh.
So you can either click the side, that'll get us to the different slides. So yeah, we just perfect.
So
Thank you.
Okay.
Right, so you can see it, right? And we've got some experience participating in various data analytics competitions together, particularly in Kaggle. And so we were very much interested in this competition as well. Well, speaking about this competition, what we wanted to do, we had several research questions. The first question, what are the strategies jockeys that they typically use in a race? This is not an utterly novel question. We rely heavily on previous research, previous literature, but we wanted to kind of make some steps forward in that direction. And the three next questions, they're going to follow from the first one. We wanted to identify which strategies are more successful, that is, estimate the effectiveness, which strategies work better in specific conditions, and for specific jockeys. So we wanted to explore that sort of variability as well. And how we answered those questions, speaking about the data, we used two variables to determine our strategies. The first variable is the horse's speed, which was computed as a difference between a horse's speed and the mean speed of the competitors. This is a very popular variable. And also, we used a variable which is called jockey's closeness to the inside of the track. We thought that's a very important piece of information because we wanted to see how jockeys are kind of spread on a track, scattered. And because we had different races of different lengths, to normalize that, we split each horse race track into 20 segments, and we calculated the averages of these two variables in each respective segment. And using the obtained values, we conducted hierarchical clustering procedure. And in this slide, you can see the results. This is a dendrogram. You can notice 4 clearly discernible clusters. They are relatively packed, saturated with observations, and quite distant. So we decided to stick to this 4-cluster solution and explore it further. And so what those clusters mean, to identify that, we can look at how our two initial variables, speed difference and inside closeness, are distributed over the course of the race. And so in a slide, you can see those distributions for the 4 clusters, and also the animated examples for each jockey, which kind of falls in a specific strategy in a specific cluster and represents it. So all those circles are kind of jockeys with horses, and the highlighted circles are the jockeys of interest. So the first cluster was called Good Start with Stability and Middle and Side Move. And as you can notice, the speed difference is slightly below 0 at the start, and then it becomes kind of on the average level. And jockeys are moving from the middle to the inside part of the track. So for all graphs which represent inside closeness, we've got 0, which is the outside part of the track, 1 is the inside part of the track. For the second cluster, we call it persistent growth and outside middle move, and as the name suggests, the speed difference grows over the time, and the jockey moves from the outside to the middle part of the track. The third cluster was called Slow Start with Breakthrough and Inside-Outside Move, and as you can notice, this big difference at the start is slightly below 0, which was probably done to save energy for the rest of the race. And then it kind of gets explosive by the end. And the jockey is moving from the inside part to the outside part. And the fourth cluster was called Persistent Decline and Middle Move. And so you can notice that the speed difference is declining, and the jockeys are on average kind of in the center of the track. So the fourth cluster is not sort of a fully fledged strategy. It's rather, it describes a situation when a jockey had kind of an unsuccessful race. But that's very handy because we compare all our 3 clusters to this 4th unsuccessful cluster and estimate the effectiveness. And this is what we did. So to do this, we used multi-level modeling with a cross-classified membership. This is a method which is oftentimes used when we've got groups in the data. And so we had jockeys and horses, and we wanted to account for that variability in the data. As for the dependent variable, we used place at finish, which was a standardized. So 1 represents the first place, 0 last place. And our main independent variables were strategies that we earlier determined. And we used, like I said, the 4th strategy as a reference group. And we also used several other variables, such as race distance, number of races for a jockey, average horse speed during the season, course type, dirt or turf, track conditions, dry or wet, and also program number as a control covariate. This is a more kind of technical representation of the method. We've got 2 levels, like I said. And on the first level, we can estimate the effectiveness of our strategies. And on a second level, we can investigate how this effectiveness varies by our groups, jockeys in our case, but you can also do that for horses as well. And this table represents our maiden findings. You can notice parameter estimates for the 3 clusters. They're highlighted respectively with their colors. They are statistically significant, and which means that they're significantly better than the 4th kind of unsuccessful cluster. However, as you can notice, the 3rd cluster, Slow Start with Breakthrough and, has the largest estimate, which means that it's the most effective on average. But we can also investigate if this effectiveness can be different depending on other circumstances, more specific situations. And this is what we did further. So in this graph, you can notice parameter estimates for the interaction relationships and the respective confidence intervals for various variables, such as race distance, number of jockeys, races, and so on. And for example, you can notice that the 3rd most effective cluster, Slow Start with Breakthrough and, becomes even kind of more successful when the race distance is larger. And another example, course type, when it's dirt, the second cluster, persistent growth, the kind of green line is the most effective. It might be effective to the same extent as the third cluster, but it's definitely effective than the first one. So you can notice this sort of variability as well, depending on different circumstances. And we can also explore the variance based on specific jockeys. So in this graph, you can, we subsampled the most experienced jockeys, and we arranged them based on the percentage of times they took from first to third places. And you can see that the top jockeys, for the top jockeys, the third cluster is way more effective than the first and the second cluster, the first and the second strategy. While for the bottom jockeys, the effectiveness of the third cluster is not really different from the second or even first. And on average, you can see very pronounced variability in the data, which means that what's effective for you may not be really effective for others. And we wanted to highlight this. And so let me just sum up what I've just said. In this competition, we detected a set of meaningful trajectories that are most prevalent among jockeys. We demonstrated that the most successful strategy is when you start slowly in the beginning and then do some breakthrough by the end of the race. But we also demonstrated that effectiveness can be different depending on other factors, such as course type, track conditions, and so on. And also, it can depend on specific jockeys. In general, we think that such a two kind of step approach is very useful when it comes to tracking data. And obviously, you can explore lots of other research questions using that approach. We also think that it will be beneficial to use additional data. You can incorporate way more variables into creating typologies and obtain a kind of more detailed analysis. And you can use more granular measures for the dependent variables. For example, you can use the exact time of crossing the finishing line. That will increase the precision of estimates. And also, you can use various attributes for jockeys and horses and see how can you exploit them meaningful in the analysis. And I believe that that will give you a lot of interesting bits of information as well, and practical information. So that's pretty much it. Thank you so much for your attention. If you have any questions, yeah, feel free to ask.
First, a couple things. One, Maggie, I just want to note for the recording that Joe Longo from the New York Racing Association has joined us. And I want to say, first off, you guys did a great job. I think you took some information that's not widely available and really created a clear and cohesive presentation that actually came up with some findings, which was wonderful. The second thing I'd like to congratulate you on, and I particularly like this, even though I'm an outlier in this, I think it was smart to judge the, you said it late in your presentation, you judged the outcomes by how jockeys finished first, second, or third, not just winning. One of the things that we've learned is that winning itself, that luck, is very important to winning, and that that using a little broader target, such as running what we would call in the money or first, second, and third, it typically adds for a more robust judgment thing. The interesting thing, you mentioned different variables at the end, and I thought the one that would be very interesting to study would be either surface or distance, being more granular with surface or distance. Because it seemed like there were some signals there that showed that the strategies could change significantly based on the distance of the race. And for us, like Joe and I would think like the surface of the race, whether it's a grass surface or a dirt surface, which are kind of distinct. Do you guys have any thoughts on that, or?
But we had this actually as well, but we just binarize it basically for wait a second. So here, right, we had we just binarize it, so it's like dry and wet track and
Dirt and turf.
Yeah, just for easier kind of interpretation. Yeah, but you can also put all other categories there as well, of course.
Yeah, so like the persistent growth in outside middle. You can see how much the green and even the red overperform on dirt, right?
Yeah.
And then in race distance, my guess is, right, like the shorter the distance, my guess is something like blue, good start with stability, might go faster because when the average horse speed is higher, right, that tends to be a better strategy, right? I'm reading that correctly, right? That with the faster horse speed, which what we would call a sprint race, right? A shorter race, they tend to go faster. The good start with stability and middle inside move is a better strategy in those races.
Compared to others,
compared to the other two strategies. Right. So that's interesting. That makes sense, right? That passes the smell test, as we say, right? In a sprint race, typically the guy who's sprintiest or fastest is going to do well. That's very interesting. When you say number of jockeys races, that's like how the guys who were more what's the right word?
Just basically the number of races
essentially. The more experience, it correlates to those strategies.
Yeah, but it's all compared to the fourth strategy, which is like unsuccessful one. So
got it.
Yeah.
Got it. Okay, Joe, you have any questions?
I thought the most interesting thing was the fact that through this, and one of the last points was the slow start with the breakthrough was the most effective strategy when American racing, particularly on on the dirt, the main track here, it's speed. And so I thought that was pretty interesting, to be honest. And the graph where you actually had the jocks and showing it's no surprise. I don't know if you guys had the information, but if you actually correlated the number of wins that these jocks have over this period of time on the track with, the strategy and where they rank in terms of, the running styles, I think you would find no surprise that the top guys in here are also the top in terms of wins. So you're seeing the correlation between the different strategies versus as you move down, it seems like they all blend together and get more muddled. So when they have a game plan, it looks like they're pretty much sticking to it. So I appreciate this one. I was big on the jockey influence thing even prior to this.
Well, the interesting thing, Joe, is let's say just looking at Javier Castellano, the first jock on the list, his blue, which is typically to the left, blue, which is typically to the left, he is particularly good at that strategy, right?
Yeah.
So it moves to the right. And it's interesting eventually if we could one day like match a horse's attributes to a rider's strengths and weaknesses.
It's funny. It's one of the things that you'll hear a lot of handicappers and whatnot, or even trainers speak to. Well, that horse fits this jock and vice versa. But now you can quantitatively say, no, in fact, he really does, and here's why. Right. So yeah.
Now, the other interesting thing to me is if you look at the red strategy, it's probably particularly good on long turf races. It's also our top jockeys are really the only guys who ride those races. Like how often does Benji Hernandez get to ride like a long turf race? But Javier, Irad, Joel, Jose, those guys are in every single long turf race. you know?
Yeah. And you think of the barns they're running for, and those barns' typical running style on the turf, it shouldn't be a surprise.
Right. Right. It's interesting that Raylu, it's always good when, you know, we all have perceptions of everyone's strengths and weaknesses. And when you see it here, you see some guys higher on the list than you think they should be or not, you know, it's,
and even if you go down the list, you see someone like, you know, Camacho, and it's certainly a function of the horses that they're getting on, but like Camacho is the top guy down at Tampa. So it's interesting, see, you know, if you try to compare them across circuits.
right. Yeah. Yeah. Let me ask you guys from the competition standpoint, what did we do good? What could we improve on? Like, tell us about your experience working with the data. Was it easy to work with? Were there things we could have provided that would have made it better for you or easier for you?
I think it was quite nice in general, at least compared to other competitions, some other competitions that they held, that you kind of provide a lot of feedback in the sense that after the competition, you were more
responsive. That was really
responsive.
unique.
I think
Other organizers never do this.
not all of them, kind of.
Yeah.
Right. In terms of
the data, I think we would appreciate as much data as possible.
No, I think in terms of actually. And I think have you seen NFL competitions that are held on Kaggle?
No, but
no. NFL, no, they're also
the NFL. Yes, the NFL.
Yeah,
yes.
sorry.
Yeah, Michael Lopez is. I'm friendly.
Yeah.
With. I wouldn't call him a
Okay.
friend, but I'm friendly with the guy who started. This is where I stole the idea from. We just.
Yeah. I think in terms of the data, probably what was missing, I think that could have been really helpful is some kind of polygons for these tracks or some kind of additional information to match
tracks themselves.
Yeah. Because I think I've seen some people were doing it manually, checking with Google Maps or something. Maybe if you're collecting this data, then maybe you also have this kind of shape files or something like this. Maybe it can be useful for future competitions.
Yes. Yeah, we saw that a lot of people were asking for that data. It was very interesting to us that like some people were very, I guess there's some level of technical flexibility or adaptation. Some people were very easily and quickly able to locate that, and others it seemed like it was a big struggle.
Mm-hmm.
Yeah. The other thing is, so it's interesting, you guys picked up, I kind of tried to leave breadcrumbs a little bit with some of the academic papers that we posted, which you guys were at least smart enough to read. And where other people were a little frustrated, but we were kind of hinting to people what we were hoping for, if you know what I mean.
Mm-hmm. Yeah.
So I'm glad to hear you guys found that helpful, because we wanted to, you know, you don't want to tell people what to do, but you want to give some ideas of where we think it would be most helpful. Okay. Joe, any other thoughts or questions or?
No, I thought it was great. I appreciate you guys taking the time and walking us through it. And, you know, I agree. The more robust, the more information we can put in here, the more meaningful it is. But, you know, I think clearly you guys came up with something pretty good here. So I do appreciate it.
Thank you.
All right. Yeah, I'll tell you, one of the things that seems like a fairly consistent result along with many of the presentations, and yours kind of hints at it, but is that the consistency of overall velocity. Not, I know you guys were doing relative velocity, right, relative to the other horses, but the consistency of overall velocity seems to be a big indicator of both current success and future success in reading a bunch of these papers. So, and it's interesting that Joe and I are probably a little surprised that that 3 is the most effective strategy, right? We probably would have gone for 1 if we're guessing. But what we're learning is that the most important thing is for your velocity not to drop off at the end.
Mm.
And that it's the horses that slow down the most that wind up losing, as opposed to the horses that accelerate. Almost no one's actually accelerating. They're only accelerating in relation to their peers. If you, right? They're not even accelerating. They're just maintaining their speed. Their peers are dropping, so it gives the appearance of acceleration. And visually, that's what you see as well, right? You see a horse looks like he's getting faster, but it's just everyone else is really getting slower.
That also might be the case. Yeah, true.
So I wonder how much more pronounced the jockey's influence would be if you had this chart separated by surface.
Yeah. Yeah, that would be interesting.
Yeah, but also, like, you cannot have all the comparison because you won't have enough information. You won't have enough games for each jockey. For each maybe for like the most.
The sample size is small.
Yeah, sample size is a problem here, of course, and therefore it's. I think it's harder to do the same for horses, for example, because you have much more jockeys with a lot of games than the horses with a lot of games, right? So it can be an issue in that sense if you want to match.
Effectively, this will basically normalize it with the collective data versus, because you can imagine we'd probably see a bunch of outliers, but maybe if someday we were able to get 5 years of data and separate the two services, this would really be interesting to see. Well, this is great, guys.
Yes, this is great. Wonderful.
Very good. Any other questions?
No, I just want to remind Joe and Wande, the next one of these is at 12:15, not 12:30. Okay, it's a little adjusted earlier. Okay, guys, thank you so much. This was congratulations. This is great.
Thank you.
Thank you.
Thank you for organizing it.
No, our pleasure. Our pleasure.